a video to help you with the 8-1 practice A. Just a quick thing, I'm going to try to run through several of these just to help you. The first one, they tell us that these two triangles are similar to each other. That's what they tell you in the directions. Or they're at number 1, that they're similar. And when we want to find first the scale factor, remember scale factor is new over old. They give us an arrow that points this way, so this one over here must be the new one, this one must be the old one. I'm sorry, this one must be the old one, this one must be the new one. So all we do to find the scale factor is we pick any two sides that match up. So I might pick the 10 here, and it matches up to the 30 over here. So we just put that in a ratio, and again, it's new on top, so 30 over 10, that means our scale factor is 3:1. And all that means is for every 3 parts in this new one, so if that's 3 inches right there, there'd be 1 inch in the old one, and that's your scale factor. Then we know that in these similar shapes, whether they're triangles or whatever they are, the angles that match up have to be congruent to each other. So the angles are exactly the same as each other. And that's what these next blanks want. So they want you to match up the angles. So I just pick like angle L, and it matches up to angle Q. So angle L has to be congruent to angle Q. So if I know angle L is 30 degrees, then that means angle Q has to be 30 degrees. And then we just match up the rest of them. Angle M matches up to angle R. Angle N matches up to angle S. And then the other part, they give you something that looks like this. There we're matching up the sides. The sides aren't congruent to each other. The sides are proportional to each other when two shapes are similar. So we just match up the two sides, and it really doesn't matter how you match them up, as long as you stay. If we take the top, let's not put that. If we take and put the lengths of this side or these sides on top, then these have to be on bottom, and it has to stay that way throughout your entire proportion, or through all your ratios. So if I pick LM right here, segment LM matches up to segment, ignore that, LM over here matches up to QR in that one. And LN in the first one matches up to QS in the segment QS in the second one. And segment MN in the first one matches up to segment RS in the second one. So you're just matching them up that way each time. Number 2, I didn't draw the pictures on number 2, just gonna do it because I'm trying to hurry through this, make it as short as possible. The scale factor, again, you're just matching up two sides. If I'm looking at them, I probably wouldn't want to throw the decimals in. So remember, you want new compared to old. So this time we're getting smaller, so that smaller one's going to go on top. I'm going to pick the 4, and it matches up to the 10. I just pick those because they don't have decimals in them. And then that can reduce down to 2 over 5. That's your scale factor. The congruent angles. There's 4 of them. And all these we can name with one letter because it's not, there's no other angle it could be. Angle B matches up to angle F. Angle A matches up to angle E. Angle D matches up to angle H. and angle C matches up to angle G. So we know that each pair of those angles are congruent. Then the proportions, again, when we're setting up these ratios and proportions, usually we'd only want 2 ratios, and later on in the packet, I'm going to show that. But now we're just matching them all up. So if I pick like segment AB has to match up to segment EF. Segment BC matches up to segment FG. Ignore that. Segment CD matches up to segment GH. And segment AD matches up to segment EH. Again, if we're actually solving something, trying to find something, then we just want to pick 2 of these. Maybe we pick just those 2. But here we're just setting them up, looking at what things match up. My picture's not drawing real well on this one, but we're going to go through and all we're going to do on this is we're going to set up a proportion, and we're going to be doing a lot of this over the next few days. So once we know that they tell us that the shapes are similar, then we're just going to match stuff up, make sure we match them up the right way. I have 1 mark there, 1 mark there. That's supposed to be a right angle, that's supposed to be a right angle. 2 marks here, 3 marks here, 2 marks here, 3 marks here. So we're just making sure that we match them up correctly. So we pick a side in the first triangle, and we're going to match it up to something in the second, or quadrilateral, sorry, and we match it up something in the second one. So if I pick this 5, put it on top there, it matches up to the 10 right there. So 5 compares to 10. Then what we need in the second one is we have to have the variable. Well, the variable's right here, so that's going to go on top, and then it matches up to the 6 in that one. So you're just matching them up. Then you're going to do your butterfly, or however you call it, the way you do it. I just do it this way. I just cross multiply and I draw this in this way. So when you're cross multiplying, that gives us 10x. Going this way, 5 times 6 is 30. Divide by 10. That tells us that x equals 3. This is what we're doing here, setting up these proportions and solving them, is the key to all this stuff. I'm going to skip 4 and 5. We'll look at 6. So 6 looks something like this. You got to make sure you match these up correctly. Notice there's 1 mark here, 1 mark there. So what's going to happen is we're going to have to sort of rotate this first triangle around to match it up to that other. So when we go to set up our proportion, if I pick the 6 over here, it matches up to the 10. And then I want to pick the x because I want to solve for x. So I pick the x, and when I rotate this around, the x is actually going to match up to that 15 right there. And that's our proportion. Then we're going to cross multiply. You get 10 times x is just 10x. Cross multiply this way, 6 times 15 is 90. Divide by 10, x equals 9. Problems 7 through 13, we have something that looks like this. First thing I'm going to do, these 2 triangles, they're telling us these 2 triangles are similar, the 2 big triangles. So if we match it up, we'd have to sort of spin this first one around to make it match up to that one. When we do that, we know that angle A here is going to match up to angle X down here. If angle A is 67 degrees, then angle X has to be 67 degrees, so we could write that in. If that's 67 degrees, this is 90. 90 plus 67 is 157. We subtract that from 180. 180 minus 157. I haven't even started looking at the questions yet. is 23, so this angle up here is 23 degrees. That means this angle over here is 23 degrees. We know that these two parts here are congruent, so if that's 5, that has to be 5. This part and this part are congruent, so if that's 15, this has to be 15. And we can find all that stuff without even messing with answering the questions yet. Number 7 says find the scale factor, so we're going to find the K, and we're trying to match up ABC to, so this is apparently ABC is the old, this one's the new, so we're getting bigger. Well, we should put new on top, old on bottom, and we find a side that matches up. I'm going to match up this 13 side, matches up to this 39 side. So I'm going to go 39 to 13. That reduces down to 3 to 1. So that means we made this shape about 3 times bigger. That's our scale factor. If you turned your scale factor over and said 1 to 3, I'm probably not going to throw a big fit about that. You just need to realize if you're getting bigger or smaller as you're going. Number 8 says find the measure of angle X. Well, we did that. That was 67 degrees already. Where I found that. Number 9 says find the length of segment CD. CD is this segment right here. Well, to do that, all we're going to do is we're going to set up a proportion. We already set up and said 39 compares to 13. And then we want CD, so that's this. That's going to compare to this. So 36, ignore that mark going up through there. 36 compares to our CD. And to make things easier on you, because I don't have a calculator here, we just reduced this 39 over 13 down to 3 over 1. So we could just make this 3 over 1 equals 36. We could use that scale factor to make the multiplying a little easier. Now when we cross multiply, we get 3 times CD equals, and you could make that an X if you want. I just leave CD in there so I don't forget what I'm doing. And then cross multiply this way. 1 times 36 is 36. Divide by 3. And you end up with segment CD equals 12. So you're just setting up that proportion and solving it. Number 10 says find the area of triangle ABC, then find the area of XYZ. Remember, formula for area of a triangle is base times height divided by 2. Well, we just found this side was 12. That's the height of this triangle. The base of this triangle is this whole thing, so that's 10. So to find that, we just do 10 times 12 divided by 2. And that gives us 60. That's one of the areas. Then the other one, this is the base. That's 30. That's the height, that's 36. So on the other one, we do 30 times 36 divided by 2. And that equals 540. And remember, with area, your units should always be some kind of units squared. I'm not going to write them down on here, but should always be some kind of units squared. Number 11 says find the ratio of the area of ABC, that's this first one, to the area of XYZ. So we're going to put, again, we're going to put the new, which is the bigger one, on top, and the 60 on bottom. To reduce this, help you reduce, you can just cancel a 0. 6 and 54 then is what we have. Let's see, the biggest number will go into both 6 and 54 is 6. 6 will go into 6 once, 6 will go into 54. 6 times 9 is 54. So the ratio of the two areas is 9 to 1. If we look, the ratio, the scale factor was 3 to 1. All we did to this was we squared it to get the ratio of the areas, and the one theorem that we had sort of told us that. Number 12 says find the length of segment BC. If we do this, if we're looking at this, the stuff that we just covered, we know that this is 90. We know that this is 90. I forgot to put those in there. So in this triangle, if we're looking at these two smaller triangles here, we know that they share that side, so that's a pair of sides. Pair of angles is the right angles. Then we got another pair of sides, the 5s here. So these two triangles are actually congruent to each other. So if in this triangle, in this first triangle, if AC is 13, then that means BC has to be 13. So one of our answers, BC, is 13. Same idea over here. If this side is 39, these two triangles have to be congruent to each other. So YZ has to be 39. So those are our two answers. 13 and 39 on that one. Problem 13 says find the ratio of the perimeters. If we, so this is 39. If we find the perimeter of this one, the new one, 39 plus 39 plus this whole thing was 30. That's 78. 78 plus 30 is 108. And then we're going to compare that to this one. 13 plus 13 is 26 plus 10 is 36. If you reduce that down, 6 will go into 36 6 times. 6 will go into 108. Let's see, 108. Maybe we should try something bigger than 6. Yeah, we'll try 6 for now. That's 1, that's 6, that's 48. 6 times 8, so that's 18. Then we can reduce that down a little farther. 6 will go into 6 once. 6 will go into 18 3 times. The ratio of the perimeters is 3 to 1. Notice that that ratio of the perimeters is the same as the scale factor of the shapes. Problem 14 says you are building a roof on a garage such that the gable of the house is similar to the gable of the garage. So these two triangles that we have here are similar to each other. The area of the gable on the house is 3,024 square feet. Find the area of the gable on the garage. Gable is just when you're looking at a house. So not much of an artist, but this is our house. The gable is this part. So all we're going to do here is we're going to set up a proportion. The proportion that we had a theorem that said the area of the first shape compared to the area of the second shape should equal side from the first shape compared to side of the second shape. But you got to remember, for area, we got to square each of those. So we know the area of the first shape. The area of the first shape is 3024. We don't know the area of the second shape, so I'm just going to leave that as A. Side from the first shape is at 42. And we have to square it. Divided by side from the garage part, the second shape, which is 14, we have to square it. If you figure out how to do this stuff on your calculator when you cross multiply and stuff here, it's going to be 42. I'm not going to do all the squaring and stuff right away. 42 squared times A equals 3,024 times 14 squared. Then we know we're going to divide by this. We're going to divide by the 42 squared, just to make my life a little easier so I don't have to punch in so many things on the calculator. I can type this into the calculator. I'm not sure what my thing is doing here. Sorry, my recorder's screwing up here. So when I put this in, I can just do 42 squared is 1764, so I got 1764 times A. Then on the other side, you can just do this as one thing on your calculator. So just type in 3024 times 14 squared, and that gives us this great big huge number, 592,704. And then we're just going to divide by this 1764 on both sides. These two cancel out, and that's going to tell us the area of the garage gable. So I already have the big number on my calculator, and I'm going to divide it by 1764, and I get 336, and our units are feet squared. Feet squared. So that's our answer for 14. Fifteen, they say figure A has a perimeter of 60 inches and a side of 5 inches. Figure B has a perimeter of 84 inches, and we don't know the side. This one, we had this on your notes, we had this theorem, perimeter from the first shape compared to perimeter of the second shape is the same as side from the first shape compared to side from a second shape. So these we don't have to square it or anything. If we're just dealing with perimeter, it comes up to where it just matches up. So we just stick in this number. Perimeter of the first shape is 60. Perimeter of the second shape is 84. Side from the first shape is 5. Side from the second shape we don't know, so I'll just let it be x. We cross multiply, we get 60 times x equals, cross multiply this way, you get, let's see, that's 420, I think. Let me grab my calculator to make sure. 84 times 5, it's 420. Divide both sides by 60. And I end up with 7. So that's our answer. The missing side here is 7. That's the side we were missing. So for perimeter, it's just perimeter compared to perimeter, side compared to side. For area, it was area 1 compared to area 1 equals side 1 squared. Side from shape 1 compared to side from shape 2 squared. So area, you got to square the sides. And that's what we're doing on this next one. So on this, I'm setting up my proportion here. Area of the first one is 4928. Area of the second one is 77. Side of the first one is 88, but we got to remember to square that. Side from the second one we don't know, so I'm just going to let that be x, but that's got to be squared also. We cross multiply here. X squared is just x squared, so it's 4,928 times x squared equals, then we can type this into our calculator, 77 times 88 squared. 77 times 88 squared, and I get this big number, 596,288, and I'm going to divide both sides by 4928. These two cancel out. We're left with x squared equals, I'm going to write it up here, x squared equals, divide that, 4928, and I come up with 121. Now that's not our answer because we got x squared equals that. So what you got to do next, remember back to your algebra days, you got to take the square root of it. That's going to cancel out and leave you with just x. Square root of 121 is 11, so the length of that side that we were missing was 11 units, whatever the units was feet, so 11 feet. Number 17, the first thing you should do on 17, you look at this picture and you should be able to figure out that it has two triangles in it. And I'm going to separate off those two triangles real quick. You got the small triangle, it's triangle A, B, C. This side is 10, this side is 12 in that. So we know that. Then you got the big triangle, which is triangle A, D, E. And we know that this side is 21, this angle is 32 degrees. This side over here, you got to be careful. It's not just the 10 and it's not just the x. It's actually the two added together, so x plus 10 on that side. And those two triangles are similar to each other. They tell us that in the up in the directions. And it says find the scale factor of the two triangles. To find the scale factor, we just pick out two sides that match up. I'm going to pick the 12 and the 21 because those are two numbers that we know. So 12 compares to 21, and then reduce that down. 3 will go into 12 4 times, 3 will go into 21 7 times, and our scale factor is 4/7. Part B says find x. To find x, we can use our scale factor, or we can use that ratio there, 12 to 21. And actually, I'm going to use the 4/7. It's the same thing. So 4 over 7, this side over that side, which was 12 over 21, but I reduced it, should equal 10 compared to that, which is 10 over x plus 10. And we said in the notes, anytime you have something like that, put parentheses around it. We're going to cross multiply, and we get 4 times x plus 10 in parentheses equals, cross multiply that way, you get 70. Here you distribute, you get 4x plus 40 equals 70. Subtract 40 on both sides, you end up with 4x. These cancel out, equals 30. Divide by 4. Grab your calculator and divide 30 by 4. 4 will go in there, 7, it ends up being 7.5. So x equals 7.5, that's the answer to part B. Part C says, find the measure of angle ABC. ABC is this angle right here. Oh, I forgot this. This is 40 degrees up here. So that's 40 degrees in there. That's 40 degrees there. Well, if these two triangles are similar to each other, and that's 40, that means this angle has to be 32. And to find, so that's that angle right there, that's 32. To find this angle, we add these two, 40 plus 32, that's 72. Subtract that from 180, and we get 108. So that angle's got to be 108 degrees. 3 angles of a triangle have to add up to 180. Part D says the perimeter of triangle ABC is about 42.4 units. Find the perimeter of ADE. So for part D, it's perimeter 1 over perimeter 2 equals side 1 over side 2. Perimeter 1, they tell us is, let's see, they say perimeter of triangle ABC, so that's the smaller triangle, is 42.4. We don't know the perimeter of the other one. The sides that match up, we know that the side from the small triangle was 12, and it matched up to 21 from the other. Then we just cross multiply and solve, so we get 12p equals 42.4 times 21. That equals 890.4. Divide both sides by 12. End up with P, the perimeter of the other triangle, 890.4 divided by 12 is 74.2. So that's the perimeter of the bigger triangle. Part E says the area of the triangle is 71.75. Find the area of the other triangle. erase all this, so I can do the area one here. So the area, for the area formula, is area of one of the first shape, area of the second shape, side from the first shape squared, over side of the second shape squared. They tell us the area is 71.75 for the first shape. We don't know the area of the second, so I'm just going to leave it as A. Sides, we just did the sides. It was 12 and 21, so it's 12 squared over 21 squared. And we're going to cross multiply and solve that. End up with 144A equals, grab your calculator and do 71.75 times 21 squared, and I get 31641.75. Divide both sides by 144. I already got that number on my calculator, so I just hit divided by 144, and I get the area is about, we'll round it off to 219.7. That's 219.7, and our units were just square units. F says is segment BC parallel to segment DE? Explain your reasoning. BC is right here. DC is right here. We know that this angle is 32 degrees. We know that that angle is 32 degrees. If we smash these two lines together, those two angles match up, so they're corresponding angles, and we can say yes. And our reason is not the reason that's on the board, but backwards of that. And it's if corresponding angles congruent, then the lines have to be parallel. On the other sheet, we're going to do just a few of these, and you should be able to finish the other sheet. Just solving proportions. We're going to cross multiply for each one of these. So on that, going that way, we get 8K. Going this way, we get 40. Divide both, this is number 1 on that sheet. Divide both sides by 8, you end up with K equals 5. That's the answer number 1 on the other sheet. Problem like 16, put parentheses around these that have more than one thing in each term. And we're going to cross multiply, and you get 5 times R plus 5. Ignore that, equals 8 times R minus 9. Here we're going to distribute on both of them. So we get 5R plus 25 equals 8R minus 72. Subtract 5R on both sides. You end up with 25 equals 3R minus 72. Add 72 to both sides. End up with 97 equals 3R. Divide both sides by 3. It's not going to come out all nice and even. Please remember, if you're coming up with something like 0.3333, all repeating, that's the same as 1/3. So write it as a fraction, not as a decimal, and don't put that repeating symbol over it. Write it as a fraction. 3 will go to 9 3 times, 3 will go to 7 twice with 1 left over, so this answer is 32 1/3. Also, if you're coming up with something on your calculator, it's like 0.66, all those repeating, that's 2/3. So write it as a fraction so that we don't have to mess around with the repeating stuff. 19, same idea, we cross multiply, we get 7 times n minus 5 equals, cross multiply this way, you get 2 times n plus 8. Distribute, you get 7n minus 35 equals 2n plus 16. Subtract 2n on both sides. You end up with 5n minus 35 equals 16. Add 35 on both sides. You end up with 5n equals 51. Divide both sides by 5. Something on like this one, when you divide it on your calculator, I don't mind if you write this one as a decimal. It comes out to be 10.2. It doesn't come out repeating or anything, it just comes out 10.2, so that's a pretty good answer.